the other concept is fractions, right? What is fractions, right? Before going to this, we will discuss one example, right? Suppose you have a four pieces of cake, right? You have total four pieces of cakes, right? You have eaten two pieces. You have eaten two pieces, right? What part you have eaten? 2 by 4, right? What you say? 2 by 4. Out of 4, you have eaten two pieces. If you have eaten three pieces, if you have eaten three pieces, what do you say? I have eaten 3 by 4 pieces, right? You say 3 by 4th part was eaten, right or no? So, how did you write? 2 by 4, 3 by 4. It is in the P by Q form, right? Any number is written in the form of P by Q, then it is called as a fraction where Q is not equal to 0, right? So, in the terms of P by Q, this PQ are called terms. PQ are called terms, right? Now, if you take a above example, what is this 2 by 4, 3 by 4? It is called part. The part you have eaten, 2/4 and 3/4. If you eat three pieces, right? What this upper part? Numerator. It is called the numerator, right? The numerator always indicates how how much part you have taken into the consideration. That means in the above example, if you have eaten two pieces, that is the thing you need to consider. That should be always numerator. And the below part is the denominator that indicates the total quantity divided equally, right? What is the quantity we have here? Four pieces. So out of four, you have eaten two. So 2/4 part. If you have eaten three pieces, what is the actual part need to be taken consideration? That should be placed as a numerator. So here you have eaten three pieces. So 3 by 4, right? So 2 by 4, 3 by 4 is called as a fraction, right? Now, in fraction, we have different types of fractions, right? We have different types of fractions. First, proper fraction. Next, improper fraction. Next, mixed fraction. Next, decimal fraction. Okay, these are the main fractions which we have to learn, right? Proper fraction. 2 by 4, 3 by 5, 11 by 17. These are called the proper fraction. To say simple, when numerator is less than denominator, if numerator is less than denominator, that is proper fraction. When numerator is greater than denominator, then it is called the improper fraction. Like 4 by 3, 17 by 11. These are called improper fractions, right? Mixed fractions. Mixed fractions, it is a combination of natural number and proper fraction, right? It is in the shape of 4, 5 by 3. Sorry, 5, 4 by 3, right? This is called the mixed fraction, right? So, mixed fraction can be changed into the proper fraction. See how we can change the mixed fraction to the improper fraction. Sorry, improper fraction. 3 5s are 15. 15 plus 4, 19. 19 by 3. See, numerator is greater than denominator, so it is called the improper fraction. So you need to note that you can change fraction from improper to mixed, right? You can change improper to mixed, and same way you can change from mixed to improper, right? So if I take other example, 7 2 by 3, so what will be the improper fraction? 3 sevens are, this part is called the natural number, ma. This part is called natural number. 2 by 3 is the proper fraction. That is the reason I wrote the combination of natural and proper fraction, right? But we will change from mixed to improper fraction, right? 3 sevens are 21. 21 plus 2, 23. So 23 by 3 is the improper fraction, right? So this can be written in other way also. 5 4 by 3 can be written as 5 plus 4 by 3, right? 7 2 by 3 can be written as 7 plus 2 by 3. This is the other way which is useful at the time of simplifications, right? Right. Clear? Right. Now decimal fraction. When the fraction is called the decimal fraction, when the denominator is in the form of tenths. What they say? Tenths. That means 1 by 10, 1 by 100, 1 by 1000, so on. If it is in the shape of this, that means, for example, 7 by 10, 25 by 100, then these fractions are called decimal fractions, right? Understood? Clear? Right. Now we see some mixed fractions, additions of mixed fractions, how you need to add the mixed fractions, right? If I take the example 4 3 by 7 plus 9 6 by 7, right? When you have these kind of numbers, you are not required to change into the improper fraction and add it. It's not required. You can write in this way: 4 plus 3 by 7 plus 9 plus 6 by 7, right? In this way you can write it. So 4 plus 9, how much? 13, plus 3 plus 6, 9, 9 by 7, right? So 13 plus this 9 by 7 can be written as 1 2 by 7, right? So we can write 14 2 by 7. So answer will be 14 2 by 7, right? In this way you can add the mixed fractions, right? Next concept is decimals. Next concept is decimals, right? What is decimals? A decimal number is a number with a decimal point in it. A number which have decimal point in it, right? Example 2.5, 3.25, 4.173, etc., right? This 2.5, after point, if we have the single digit, then it is called 1/10. After decimal point, if we have two numbers, then it is 1/100th, right? Decimal point, after decimal point, if you have three numbers, then you should have 1 by 1000, three zeros. So when decimal points increases, the number of zeros increases, remember, right? So how can I write this? 2 5 by 10, right? You can transform into the mixed fraction also, or you can transform into improper fraction also. This can be written, 2.5 can be written as 2 5 by 10 or 25 by 10. See, when you multiply 10 2s are 20, 20 plus 5, 25 by 10, right? You can return decimal number in the mixed fraction or improper fraction. Right? Clear? Right. Now we'll see decimal fractions also. We'll see place values and face values of a number. Right? Very, very important. This is a place value chart. Now we will take one example, one number example, and we will see the what is place value. Right? If I take one number, I have taken 5-digit number. 1, 2, 3, 4, 5. This is a 5-digit number, right? This is a 5-digit number. Always you need to come from right to left. You need to always compare from right to left, right? This way. 7, 2, 3, 6, 5, right? What this place is called unit digit place. What they think? At the end of the number, the place is unit digit. What this will be? Tens digit, right? This will be hundreds digit, right? This will be thousands. This will be 10,000, right? No. The place of 7 is unit digit place, right? So it should be multiplied with 1. This is the place value. What will be the place value of 7? 7, right? If the question is asked, what is the place value of 7 in the number 56,327? Then it will be 7. The tens, so 2 into 10, right? The place value of 3 is 3 into 100. Then place value of 6 into 1000. The place value of 5 into 10,000, right? So if the question is what is the place value of 3 in the number 56,327, then the answer will be 3 into what is the place? The 3 has been in hundreds place, so it will be 3 into 100. It is 300. See how the 5-digit number is formed? 50,000, right? Plus 6,000 plus 300 plus 20 plus 7. This is the way we need to find the place value of particular number, right? Shall we solve one more example? Right. 4327, right? 4327. What is the place value of 4? What is the place value of 4? Right? We need to compare from the right to left. Unit, tens, hundreds, thousand. So the place value of 4 is 1000. 4 into 1000, right? 4,000, right? See here. Unit, tens, hundreds, thousands, 10,000, right? From right to left you need to go, right? Understood? Now another example, if I take the decimal point, right? 327.98. This can be expressed as, how we can express this number? How you express the 56,327, right? The number into its position, right? The same way here also we need to do the same thing. So this will be the unit digit, not the unit digit. See, you have a decimal point in between. Before the decimal point, this is the left hand side, this is the right hand side, right? This left hand side, it is called as integral part or whole number, right? This is called as decimal number. This is called as decimal number, right? So 0.98 is called the decimal number and 327 as a whole number, right? Now how do you express this number? 3 into 1000 plus 2 into 100, sorry, we have only 3 digits, right? See, 3 into 100 plus 2 into 10 plus 7 into 1, because we have only 3 digits: unit digit, tens digit, 100 digits. After decimal point, it should be 1/10, right? 9 by 10 plus 8 by, sorry, this is what after decimal, what it is, 1/10, 100, right? After decimal point, what we need to do, 1/10, hundreds, right? After decimal point, we need to go from left to right. Before decimal point, first you will get the unit digit, tens, hundreds, but after decimal point it is reverse, tens, hundreds, thousands. So should not confuse this one, right? So it should be 9 by 10 plus 8 by 100, right? If you have another number 7, then it should be plus 7 by 1000, right? When the decimal is increasing, the number of zeros increases, right? From left to right. After decimal point, you need to left to right. Before decimal point, from right to left. So when you get the decimal number, while expressing the numbers, you should be careful, right? Understood? Clear? Right. Shall we work out one more problem on decimals? Right. Another example, we will take 24.987. Now I need place value of 7. Now I need place value of 7. Where is the 7? After decimal point, right? After decimal point. What happens after decimal point? This is 10th place, and this is 100th, and this is thousands, right? So it will be 7 by 1000. If I need the place value of 2, place value of 2, what happened before decimal point, right? This will be unit place and this will be the tens place, right? Understood? So the place value of 2 is 2 into 10. It will be 20, right? Clear? Right, good. Next, we see the face value, right? Face value is different from the place value. Place value always indicates the position. Face value always indicates its value. That's all. For example, if I take 8637, the face value of 6, the face value of 6 is 6. Will not change. The face value of the number will not change. So the face value of a digit is always fixed. Okay? Face value of a digit is always fixed. Right? If the same problem, place value of 6. Place value of 6. What will be the answer, ma? Tell me. 600. Right. So if the question is given 8637, what is the face value of 6? The value will be 6. What is the place value of 6? 600. Right? If we take another example, face value of 9 and place value of 9. What is the face value of 9? It's 9 only. What is the place value of 9? 9 into 10, right? 90. Understood the difference between the place value and the face value? Right? Understood? Clear? Good. Now we will see how to add the decimals, multiply or divide, right? Right. Now we see additions of decimals. How you need to add the decimals, right? For example, if I have the number 23.1 and 1.23, right? Right. See how you need to add 23.1. Of always compare with the decimal before decimal. Always compare with the number before decimal. Where is the 1? Here. So this decimal point is important, right? So you need to write 1.23. If nothing is there, then it is 0. Then add it. 3, 3.4, 24.33, right? Same way, subtraction. Same way, subtraction. It is similar to the addition, right? 2, 3.10, 1.23. Then subtract it, right? 10 minus 3, 7. So here 8, then 1, 21.87. Now multiplication. How to multiply the two decimals, right? 13 into 1.1, right? 13 into 1.1. Don't worry about the multiplication. You think that there is a no decimal. You think that there is a no decimal. Then how you multiply? 13 into 11, 143, right? See the place of the decimal. See the place of the decimal. After one digit, right? After one digit. So you need to point after one digit. 14.3. Simple. Right. Shall we see one more example? Right. Good. 3.8 into 4.6. 3.8 into 4.6. Check it, ma. Assume that there is no decimals. Then what do you do? 38 into 46. Right? What will be the result? Right. 1748. Right. Now see here. In the prior example, you have only one decimal. Right? Here you have two decimals. So you need to put a decimal point after two digits. So answer will be 17.48. Understood? Clear? Right, right. Now division. How you divide the decimals, right? 65 divided by 1.3, right? 65 by 1.3, right? See, very important. 1.3, right? So you have only one decimal. So you need to multiply, you need to remove the decimal and you need to multiply 10. If you have the two decimals, sorry, if you have a decimal before two numbers, right? I mean that 65.1.32. Then you need to remove the decimal and multiply with 100, right? This is the way you need to do with the decimals, right? Clear? Right, right. Now we will see different types of decimals and very important in exam point of view. Right. Now we see the different types of decimals, right? There are two types of decimals: terminated and repeated or recurring decimals, right? Terminated decimals means, suppose you have a 4 by 5. How you convert into the decimals? 0.8. right? Suppose if I have 10 by 8, right? 1.25. These are the terminated decimals, right? Recurring decimals or repeated decimals. Suppose I have 1 by 3. What is happening? 0.03333. It never ends. That is called the recurring decimals. Another example, uh, if I take 8 by 3, what do you have? 2.66666. These are called the recurring decimals, right? Again, recurring decimals have divided into three parts, right? Pure recurring, mixed recurring, and then third one, non-recurring, right? What we have? Pure recurring, mixed recurring, and non-recurring. So first, pure recurring. Pure recurring examples are 0.33333, so on, right? Or otherwise 2.66666, so on, or otherwise 9.454545. This way, this is called the pure recurring. It can be expressed as, the recurring decimals can be expressed as bar. Simply, instead of writing that all 0.3333, if you put a bar, then it means that is recurring decimal, right? So here you will put 2.6 bar. So in this example, you will put 9.45 bar, right? Then if the bar, that bar indicates that 9.45454545, right? If an example like 8.67 bar, then that indicates 8.677777. That is the meaning of the bar, right? Now, mixed recurring. Example for mixed recurring is 3.654545 in this way, right? This is called the mixed recurring, right? Sorry, we have 54. Otherwise, I will put in another way. This I will put as 67. That would be better and no confusion, right? Right. Now 3.6745 bar. Non-recurring. Non-recurring means a decimal number in which there is no any regular pattern of repetition of digits, right? For example, you have number 6, 7, 8, some number 2, 6, 3, like that. No repetition, right? Non-recurring of the decimal point, right? And we see the problems on pure recurring and mixed recurring. These are very, very important in the exam point of view, right? Right. Understood the decimals part, concept, right? And the types of decimals, right? Now we do some problems on recurring decimals, okay? Right. For example, we will take 5.732 bar plus 8.613, right? First we see how we need to convert the recurring decimal into fraction, right? Recurring decimal to fraction, right? First we see and then solve some problems, right? Right. First we see the procedure, and later I will tell the trick how we can write directly the recurring decimal into fraction, right? We will take one example. Suppose I need to convert 0.7 bar into the fraction. So this number can be written as 0.77777, so on, right? Let x equal to 0.77777, so on. If I multiply with 10 both sides, then I will get 10x equal to 7.7777, so on, right? So 10x equal to, I will make 7 plus 0.7777, so on, right? See here, what we have assumed 0.7777 x, right? So I will put as x. So 9x equal to 7. So x equal to 7 by 9. This is the procedure, right? We will see one more example. Now we will take the 0.17 bar, right? 0.17 bar. So this can be written as 177777, so on, right? If I assume x equal to 0.177777, then see why we multiplied here 10, because we have only one decimal bar, right? Now here we have two decimals, so I will multiply with 100. So I will have the number 17.7777, right? Now 100x equal to this, I will write as 16 plus 1.7777, so on, right? Now how I get 1.7777? If I multiply with 10 on both sides, if I multiply 10, what happens here? 10x equal to 1.77777, right? I get the same thing, right? 100x equal to 16 plus 10x, right? So 90x equal to 16, x equal to 16 by 90, right? Understood? Clear? Right. Now you learn the procedure, right? But this is not required to do if the same thing you get in the exam, right? It is very easy to remember the trick, right? Now we will discuss the trick, how to do directly, right? Right. Same example, 0.7 bar, right? Simple to remember. If you have the bar for one digit, then you need to write 7 by 9, right? If you have one bar, you need to write 7 by 9. If suppose if I have 0.54 bar, then that 54 by 54 by 99, right? Understood? Now if I give the number 357, 357, 357, so on, how you need to write this one? 2.357 bar, right? And this one you need to write 2 plus 0.357 bar, right? So 2 plus 357 by 999, right? Understood? So this is a mixed fraction, right? So 2357 by 999, right? Or you can convert into the improper fraction also. How much you get, ma? Right. 2355 by 999, right? In either way you can write it, right? Understood how to convert from recurring decimal to the decimal? Right. Now this is the pure recurring decimals, right? Now I will tell how to convert the mixed recurring decimal into the fraction. Which is the mixed decimal? This one, right? Because it one has left alone and the bar is only for 7, right? 0.17 bar. If the bar doesn't have for the both the numbers, right? So what the number it has been left here? 1. So the numerator will be 17 minus 1 by 90. You need to write 90. Instead of 99, you need to write 90. Why you need to write 90? Because the bar is for only 1. That is the reason 9. And the no bar for 1 digit. If suppose you have 117 bar, then you need to write 900. Then you will have 117, sorry, right? In this case, you will write 117 minus 11 by 900. So you will get 106 by 900, right? Here you will get 16 by 90. The same thing we got here, right? This procedure is not required to remember, but sometimes it is better to remember, but not required. Okay. So directly you can write in this way. Shall we work out some more examples on mixed recurring decimals? Right, see it. Now I'll put as 0.8737373, right? This you convert into the fraction, right? So first I can write this 873 bar, right? So this I can written as 873 minus 8 by what I need to write? I have bar for 2 digits. So I will write 2 nines and there is a no 1 bar, right? There is a no bar for 1 digit. So I will put as a 0. So it should be 865 by 990, right? Understood how to use? Right. In another case, 0.78943 bar, right? Tell me ma, tell me the answer. Right. 78943 minus 78 by bar is for how many digits? 3 digits. So 3 nines. There is no bar for how many digits? 2 digits. So 2 zeros. Understood? How you need to write? So it will be 78865 by 99990. Understood? Right, right. We will do one more example, right? Write 6.6 bar in the form of P by Q. How you need to do? 6.6 bar, right? 6.6 bar means 6 plus 0.6 bar, right? So 6 plus, how can I write this one? 6 by 9. So 6 by 9, or otherwise you can write 60 by 9, right? 3 20s, 3 3s, right? Clear? Right. One more example, right? Add the recurring decimals now. 0.63 bar plus 0.37 bar, right? How you add it? So 0.63 bar, we have total bar for 2 digits. So 63 by 99 plus 37 by 99, right? So 63 plus 37, 100 by 99. Clear? We will discuss one more example. Write 3.5 24 bar in the form P by Q, right? Right, see. By avoiding the earlier steps, we can do very simple 3.24 bar. Instead of writing 3 plus 0.24 bar, directly you can write 324 minus 3 by 99, right? So you will have 321 by 99. Same thing you will get here. No need to worry. You can check it, right? What is the earlier example we have taken? 6.6 bar. See here. 6.6 bar. You can write 66 minus 6 by 9, right? So 60 by 9. The same thing we got here, right? You can write directly, right? We will take another example. 12.34 bar plus 28.26 bar, right? Now what I can write here? 1234 minus 12 by 99, right? So plus 28.26 minus 28 by 99, right? Check it, check it, right? What the number you are getting here? 1,222 by 99 plus 2798 by 99, right? Now add the numbers. What you are getting the number? 4020 by 99, right? You can further simplify your wish. So you can write 1340 by 33. So 11 threes. So no, there is not 143, right? So 1340 by 33, right? Understood? Right. Now we have completed fractions, decimals, and the types of decimals, right? The concept of fractions is completed, right? We will go to the further concept.